Okay, so let's look at this problem 16, the APV or adjusted present value. And there's really nothing fancy about adjusted present value. You're just going to take a series of cash flows, determine a discount rate, and discount those cash flows back to present value. The only sort of trick here is, and what they mean by adjusted, is in addition to just the basic cash flows going in and out, you're also going to take into account any tax benefits of debt, which we've discussed before. In most countries, interest on debt is tax deductible, so to the extent you borrow and pay interest expense, it reduces your tax bill. And so in the adjusted present value method, we take into account those tax savings as part of the overall cash flows. If we weren't borrowing anything, if it was an all equity financing, then there would be the adjusted present value and present value would be the same because there'd be no tax savings. You'd just be looking at the basic cash flow. But they tell us here that we will be borrowing some money, so we know we're going to need to do two things. We're going to need to determine the discount rate. It's not going to be 12% because it's going to be a blend between the 12% and 8%, since we got both debt and equity financing this project. And then we also know we're going to have to compute the tax savings. So I got started here, got a little bit of a head start on here. So it says we're going to invest $1 million now, so I'm calling that year 0. And when I'm doing these present values, I tend to put negative and positive signs just to make sure I understand, keep straight what's a cash outflow. So this is $1 million cash outflow, an investment in year 0. So that means, right now. And then it says we expect after-tax returns at T equal 1 of 600,000, so that's a positive, and T equal 2, so I'm just calling this, to keep it simple, years. And here's, it doesn't say it here, is that the beginning of the year, year 1, or the end? I assume because here they have T equals 0 and T equals 1, there's a 1 year gap between here. In other words, that cash flow comes in at the beginning of year 1, not the end. Otherwise, there'd be a 2 year gap between those first two cash flows. So those are just the basic cash flows. Now, we know because it's an adjusted present value, we're going to want to figure in the cost savings, tax savings. And it says the debt will be repaid in 2 equal installments of $150,000 each. So let's sort of go down here. So we start off with a $300,000 loan for year 0 times 0.08%. So I can almost do that in my head, but 300,000 times 0.08. So we've got $24,000 of interest expense in this first year. And then we make a payment of $150,000. So for year 2, we have $150,000 outstanding times 0.08, which of course is half of that, $12,000 of interest. And then the tax savings is 30%. So that's $7,200 of tax savings in the first year, and of course half of that in the second year. So again, timing is always a little bit of a question here. That tax savings, when are you going to assume it happens? At the beginning of the period, at the end of the period? I'm going to assume at the beginning of the period. So now our total tax savings, our total cash flow, including the tax savings, is this. So these are the series of tax flows, cash flows, that we will discount back to present value. So the next question is, well, what discount rate do we use? Well, the problem told us 12% for equity and 8% for debt, and it implies a 30% tax rate. It says $0.3 savings for every, 0.3 tax savings for every dollar of interest expense. So now we can go back to this good old weighted average cost of capital problem. And these are the figures from the prior problem. But the total value of this project is $1 million. The equity is $700,000, so it's funded 70% with equity, and we know the rate of return on equity is 12%. We know the debt is $300,000. So out of the $1 million, so $300,000 over the total $1 million investment in the project. Tax rate in this case is 30, not 35, and return on debt is 8%. So that's how you just plug those numbers in, and that will give you your weighted average cost of capital. And then you just discount the cash flows, which we've computed to be these three, back at that weighted average cost of capital. And you can do that in Excel, but it's pretty easy to, I didn't do it, but it's somewhere between 8 and 12%. Let's just say it's 10%. So the discount could be, you multiply this times, well, this is going to be by 1 because at the very beginning of the period. This would be 1 plus 0.1. Again, I'm just assuming the weighted average cost of capital is 10%. That's certainly not true. Multiply it by, raise it to the -1 power, or you can divide it and just raise it to the 1 power. And 1 plus 0.10 raised to the -2 power. And you can do that math. Or you can just put it in Excel. So I may have made a math problem here, a math error here, but I think that's the general idea. Hope that helps.